Hey everyone, welcome to your homework. 3.18 today is mostly review of what you will see on your test tomorrow. So please make sure to listen to the video. I'm actually going to give you two code words today, one randomly and one at the end, to make sure you're listening to the whole thing. All right, so we start off with the domain and the range. Remember that domain is the inputs and range is the outputs. So domain are our x values and range are our y values. So when we're looking here on this chart and we're looking for our x value. What is the lowest x value? What is the greatest x value? And that gives us our domain. Here it is less than or equal to and greater than or equal to because we can see that those circles are filled in, right? Here it includes those points. Our range then is the highest point and the lowest point. So the lowest point here is -1, and then the highest point that the y value reaches is 5. And they, again, are points that are included on the graph, so they are less than or equal to because they are part of that. So here we are going to try it out and look at, this is the domain or the inputs and our x values. And so x here is greater than or equal to -7 and less than or equal to 4. It is between these 2 points here. And then if we're looking at our range, our highest y value is 8 and our lowest y value is -4. And so y is going to be greater than or equal to -4 and less than or equal to 8. Again, this 8 being the highest point and this -4 being the lowest point. All right, our absolute value is the distance from 0. So remember, this is always going to be a positive number. These are our modulus bars or the absolute value notation. So we have this example, Ms. Pritchett is doing an experiment. Let's fix that. An experiment, and the room has to be -10 degrees Fahrenheit for the experiment to work. So function P gives the absolute temperature error as a function of the room temperature in degrees Fahrenheit of x. So whatever the temperature is in the room, the difference between that and -10 tells us what the absolute temperature error is. So here, if the room is 0 degrees and it's supposed to be -10 degrees, it is 10 degrees away from what it's supposed to be. And because we are going to put it in absolute value, it would be, right, -10, right, 0 minus 10, we're still going to make it a positive value. It doesn't matter that it's negative. 0 degrees is still 10 degrees away from -10. What is the equation you would use to represent this function? So this is the correct equation here because, we have a freezing error. Hopefully it catches up, but I'll go ahead and explain why. Because we're subtracting the difference of -10. So if we were to plug in 0, 0 minus -10 becomes 0 plus 10, which is 10, right? And so if I said, for example, the room was 1 degree, right? If I put this in here and I say 1 plus 10 equals 11, the difference between 1 and -10 is 11, right? But if I were to use x minus 10, and I put 1 minus 10, that would give me -9. The absolute value of -9 is 9, but it's not 9 degrees from -10. It's 11 degrees. So this has to be a positive inside there because it's the same as x minus a -10. So again, when you are doing these, if you're not sure which function works, try a point that you know exists. So 1, 11 would be one of our absolute value points because if it's 1 degree, it's 11 degrees away from the temperature it should be. And so if you plug that in and it works, then you know you've done it correctly. So I plug this in, I get 11 equals 1 plus 10. That is true. If I were to plug in a different value, so if I plugged in 1, 9, for example, and I said 9 equals absolute value of 1 plus 10, right? Then you know that there's something going to be off there, okay? So test a point that you know works. And then it says if P equals -2, so the difference between the actual correct temperature and the temperature we were trying to get it to be is 2, then it could either be -8 or -12 because it's 2 away from -10. They're both 2 away from -10. All right, so let's look at this example with my plants. So I'm supposed to give my plants 2 grams of fertilizer. If I give them too much, they get what's called fertilizer burn. The leaves look crispy, and too little and they don't survive, right? So function f gives the absolute fertilizer error as a function of the fertilizer amount in grams. Which of the following are true? So you're going to see a very similar question where you have to select what is true. So if the plant receives 4 grams of fertilizer, f of x equals 2. Well, that is true because if they get 4 grams, then that's 2 grams more than they need. It's a 2 gram difference. When the plant receives 0 grams of fertilizer, the absolute fertilizer error f of 0 equals -2. This is not true because absolute fertilizer error should be only in positives, and so we're not measuring with negatives. Letter C, when the fertilizer given is 10, f of 10 equals 8. This is, in fact, also true because 10 grams is 8 more grams than I need. D, the equation f of x equals x plus 2 represents the absolute fertilizer error. So we know, for example, that 2 and 4 are inputs and outputs that work. So 4, 2 is an input and output that work. If I plug in 4 here, I would get 6, not 2. So this is not it. But the next equation says x minus 2. So if I plug in 4 minus 2 equals 2, that is correct. So this is the one that works. Again, here, because I am doing the amount of fertilizer that it gets minus the amount that I'm supposed to get, gives me x minus 2 in absolute value. And remember that that would shift our graph to the right. When f of x equals 1, the fertilizer amount could be 3 or 1 grams. That is also true because it's supposed to be 2, right? This value is 1 too much, and this value is 1 too little. All right. So piecewise functions, a review of this. You guys have been doing really well with this. The main thing I want you to remember is if it is less than or greater than, it is an open circle. If it is less than or equal to, it is a closed circle. So these questions that you have here, you do need to answer about this graph. How much does it cost for 3 hours? So if we interpret here anything after 2 hours all the way to 12 hours, it's going to be $8. How much does it cost for 15 minutes? Well, anything before 30 minutes is going to be $4. And then it says, how much does it cost for 1 hour? So 1 hour is tricky because there's 2 places here, but this is open, so it's going to be this one here, which is $6. And you can double check here, less than or equal to 1, 6. Now over here it's asking us to graph our own piecewise function. The maximum charge is $12 a day. So once we get past that 5-hour mark, it's going to be $12 regardless. Okay, so if we have f of 2 between 0 and 1, it's $2. Notice it's an open circle on 0 and a closed circle on 1. And then we're looking at 1 to 2 hours is $4. Open, closed. 2 to 3 is $6. So open here, closed here, right? And that's all we're doing is building this graph up in increments, and we're going up to 8. Open, closed. And $10 for between 4 and 5 hours. And then after 5 hours, we're going to have open here, and then all the way, oh, I did that on the wrong line though. I'm going to fix that, it should be on the 12. Looking here, all the way to 24 hours, right? It's going to go ahead and be that $12 cost. All right, our absolute value graphs. So make sure to read this and memorize it. You just have to memorize it when it's subtracted within. So if you have x minus 1, we're moving it to the right. If it's added, we're moving it to the left. If it is outside of the modulus, it's going down, subtracted, inside, 1. Again, if you test the vertex in there, if it works, you know you've done it correctly. So here the absolute value function is the absolute value of x minus 2. And if we plug in, this is 0, -2, right? If I plug that into my equation and I say the absolute value of 0 minus 2 equals -2, that is true, so I know that that is the right equation. So for this one, I'm going over 2, right? And so it is across side to side, so it's going to be within the modulus. So f of x equals x minus 2. And I'm using minus 2 because I moved to the right, but also if I test this point, 2 comma 0, and I plug in 2 minus 2 equals 0, that is correct. So I know that it works. If I had chosen plus and then I plugged that in, it would not work, right? And so we need to make sure that we are doing one that demonstrates what our actual vertex is here, which is 2 comma 0. Okay, just to show you, if we did y equals, or f of x equals x plus 2, and I plugged in this vertex, it would be 2 plus 2 equals 0. That's not true, right? Because 4 does not equal 0. So you know that you've done something wrong here, and instead of a plus, this should be a minus sign. So if you're not sure if you did the plus or minus sign correct inside the modulus, you can test it using your vertex. All right, inverse equations, remember we are solving for the opposite variable, the other variable, by using inverse operations. So generally our x and y values are our f of x, and our inputs and our outputs are switching. So Charlotte makes $16 an hour. Write a function that represents how much she makes an hour. All right, so if I'm saying this, right, we have f of h equals 16 times the number of hours she's working. If I want to find out, that tells me then how much she is making. If she made $32, how many hours did she work? So I would say 32 equals 16h, and then divide both sides by 16. So h equals 2. This would tell me she worked 2 hours. The inverse function then is f of h equals 16h. If we divide both sides by 16, we get h equals f of h, or y, over 16, and this represents hours worked. All right. For these, it asks you to find the inverse function. So all you're doing is solving for x. So y of x equals 65 plus 5x. Subtract 65 on both sides. We get y of x minus 65 equals 5x. Divide both sides by 5. We get x equals y of x minus 65 over 5. This one is done. That's A. All right, if we're doing B, same thing. F of t equals 3.5 minus 0.5t. We're going to subtract 3.5 first. So f of t minus 3.5 equals minus 0.5t. And then divide both sides by negative 0.5. Okay, and so this will cancel out because that's 1, and so this is your answer right here. So for letter C, I want you to do that one on your own. What I will acknowledge here is be careful with this denominator. To get that out of the denominator, the opposite of division is multiplication, so you're going to multiply. So for C, you should be writing your own answer, and I'll be looking to see that you have done that. All right. Moving into the next part of our review, there's just a couple of questions here to get your mind going. A college student borrows $360 from his cousin to repair his car. He agrees to pay $15 per week until the loan is paid off. Function L represents the amount owed. All right, so L of W equals 360 is the amount he owes, minus he's going to pay $15 a week, so $15 per week. This is our equation using function notation. You could have also, of course, written this as L equals 360 minus 15W, but we want to show this in function notation, so I'm writing it like this. It says write an equation to represent the inverse of this. So if we have L of W equals 360 minus 15W, I'm going to subtract 360 from both sides. We'll get L of W minus 360 equals negative 15W. And now I can go ahead and divide both sides by negative 15. And so we'll get W equals L of W minus 360 over negative 15. All right. You can also simplify this by dividing here and then dividing here, but you can also leave it as it is. That's perfectly fine. All right. How many weeks will it take for the student to pay off the loan? So if the student pays off the loan, then the amount that they owe now is going to be 0, right? So they no longer owe any money. So if we substitute 0 in here, 0 minus 360 over negative 15, right? And then divide, you're going to have a negative divided by a negative here. So if we do 360 divided by 15, we get 24. So it's going to take him 24 weeks to make that money and pay it off. Number 2, a family bought a used car that had been driven 12,000 miles. This table shows the distance in miles the car has traveled every year since the purchase. So this is the total miles traveled in the years. It says, on average, how many miles does the family drive every year? So this is our average rate of change. This is our X, this is our Y, if that's helpful to label. You're going to take the latest Y value, so 21,750, minus the earlier value, divided by 12,000, all over the time, 3 minus 0. So 21,750 minus 12,000 gives us 9,750 divided by 3. So they've had it for 3 years. And so that is 3,250 miles per year. Remember, this is unit rate. It is your slope. It is how much per year approximately they are driving. Write an equation that could define function m, which gives the total miles traveled t since the purchase. So we have m of t, okay, miles traveled, and then we are doing our slope, which is 3,250 times the number of years, plus the starting value is 12,000. Right, because they bought a used car, so the car already came with some miles on it. And so then this will tell us the total number of miles on the car after t years. Now, if I want to find the inverse, I'm going to start by subtracting 12,000 on both sides. And then I can rewrite this. M of t minus 12,000, not 2,000, minus 12,000 equals, that's 0, 3,250 t. Then divide by 3,250 on both sides. This is 1 now, so we're left with t, and so this is your inverse. It says if the family's driving trend continues, when will the car have traveled 50,000 miles? So to do this, this is the miles, so I'm going to plug that in here. 50,000 minus 12,000 over 3,250 will give us the time it takes. So let's do that. 50,000 minus 12,000 divided by 3,250 gives us 11.69. So it will have traveled this between 11 and 12 years. Okay, more specifically, sometime in the 11th year. All right, the number of chirps that crickets make, I don't know why they keep coming back to crickets, but they do, is related to the temperature. When the temperature is between 12 and 38 degrees Celsius, we can tell the temperature by counting the number of chirps. A formula that is commonly used to find the temperature in degrees is count the number of chirps in 25 seconds, so chirps, divide by 3, and then add 4 to get the temperature, equals temperature. All right, so it says let m be the number of chirps. So instead of c, oops, erase this. Nope, doesn't want to erase anymore, it's fine. This is m plus 4 equals, and c is the temperature. So let me just adjust this here, use the ones it wants me to use. So c equals m divided by 3, right? The number of chirps divided by 3, and then plus 4. So when it says what is the temperature when 84 chirps are heard, okay? So if 84 chirps are heard, we would have 84 divided by 3 plus 4 equals the temperature. So 84 divided by 3 plus 4 gives me 32. So it would be 32 degrees Celsius. So write an equation that defines c as a function of m. So c of m equals m divided by 3 plus 4, which we very naturally did up here. How many chirps would we expect to hear in 25 seconds when it is 14 degrees? So if I replaced this with 14 degrees equals m divided by 3 plus 4, I can solve now by subtracting 4 first. I'll get 10 equals m divided by 3. And now I want to get m by itself. So this is division, so I'm going to multiply by 3 over 1 on both sides, because 3 divided by 3 is 1. And we'll get m equals 30, so that means it chirped 30 times. So this chirps. Write an equation that defines the inverse. So C of m equals m divided by 3 plus 4. Subtract 4 on both sides. C of m minus 4 equals m over 3. Multiply the whole thing by 3 to cancel this out 3 times. So it'll be 3 times C of m minus 4 equals m. You can also, if you want to, distribute this and say 3 times C of m minus 12 equals m. I'm going to leave it like this just because that's a whole lot of parentheses, right? So if you needed to calculate this, you could calculate it. All right, and our last problem is two cyclists, A and B, are going on a bike ride and are meeting in an orchard. They left home at the same time. Functions A and B give their distance from the orchard in miles after riding for X hours. The functions are defined by these equations. Which cyclist lives further away from the orchard? So the starting amount is how far away they are from the orchard. So A of X is further from the orchard, right? Because they're starting at 48.5 away. Who will get to the orchard first? How much earlier will that cyclist arrive? So to figure out how long it's going to take them, when I want to be there, right, this is the distance away, it would be 0. So 48.5 minus 21x equals 0. Subtract 48.5 on both sides, so I'll get negative 21x equals negative 48.5. And then I'm going to divide both sides by 21, negative 21 rather. All right, so that will be 48.5 divided by 21 gives me 2.3 hours. That's how long rider A is going to take. This one here is going to be 42 minus 14.8x equals 0. Subtract 42 on both sides and then divide by 14.8 and we will get 2.83. So rider B is going to take longer, which means that rider A will get there first, and they're going to get there by, it looks like 0.5 hours, so 30 minutes. It says, is there a time when the cyclists are the same distance from the orchard? So to find when the cyclists are the same distance from the orchard, we're going to set these equal to each other. So 48.5 minus 21x equals 42 minus 16.8x. All right, so now I can subtract 42 from both sides, and I will get 6.5 minus 21x equals negative 16.8x. Now I need to combine my x values. Let me fix that. So I'm going to add 21x to both sides. And so we'll get 6.5 equals 16.8. Negative 16.8x plus 21 gives me 4.2. So we have 6.5 equals 4.2x. Divide both sides by 4.2. 6.5 divided by 4.2. And we get x equals 1.55. So at around an hour and a half, they are at the same distance away from each other. Okay? All right. I forgot to do the two code words. So you can tell me that you didn't do a code word in the middle of the video. And then your code word for the end of the video is pi, the mathematical pi. Okay. Happy homeworking. Let me know if you have any questions. If you need help, text me to ask for help. If there's anything you want to go over, I would strongly recommend the things you go review are your absolute value, when it moves to the left, when it moves to the right, and what equation goes with that. And I would also recommend that you review your average rate of change. That is going to keep coming back because that is a big part of math is your slope. So your average rate of change, remember, is your later value, your later y value. I'm going to put it here, y2 minus y1 over x2 minus x1. Your y values, your outputs go here in the denominator because it's rise, up and down, over run, side to side. and you're doing your later value first, okay? The most recent value. All right. Happy homeworking. See you tomorrow.